All right, in this lesson, we're going to be using z-scores, normal distributions. We are going to learn how to use this table, this standard normal cumulative probability table. In other words, it's a table of the probabilities to the left of any z-score that you want. We're going to use this table to find probabilities in lots of different situations. Problem number 1. The length of human pregnancies from conception to birth varies according to a distribution that is about normal with a mean of 266 days and a standard deviation of 16 days. Okay, so we're talking about the length of pregnancies. Now, what percent of pregnancies last less than 240 days? Okay, so that's about 8 months. But let's stick to days. All right, so this is a 4-step process, which is why I made these boxes to help guide you. Step 1 is to draw yourself a picture of the situation, a probability distribution, if you will. So just do your best, draw yourself a nice bell curve, you know, like you do. Okay, just do your best. Go ahead and drop a line right down the middle and label it with the mean. Okay, it said we had a mean of 266 days. So I'm going to put 266, and I'm going to label this days. Okay, the labeling is very important. All right, sometimes I don't really hold you guys accountable for the units, but for this I will. So days. All right, now you're going to go ahead and mark down the value that we're really trying to find out about. All right, we want to know where, what percentage of pregnancies last less than 240 days. Okay, so mark 240 days on your graph, on your distribution. All right, just put it, I mean, obviously it will be to the left of the mean, so just put it over here somewhere. Doesn't have to be precise right now. So there's the 240 that we're worried about. Now we're going to shade one side or the other of this 240. We want to know what percentage of pregnancies last less than 240 days. So we will indicate that by shading in the part of the distribution that is to the left of 240, because that's the less than part. All right, so just go ahead and shade that in. All right, so that is step 1 complete. Now, step 2, we need to standardize this by converting this to z-scores. Okay, so let's find the z-score associated with 240 days. So you know that the z-score is going to be your actual value minus the mean divided by the standard deviation. Okay, so that means our z-score is going to be the actual value of 240 minus a mean of 266. Whoa, it's a bad 6. Okay, divided by the standard deviation, which was 16 days. 16 days. Okay, put that in your calculator. All right, I'm getting negative 1.625. Now for z-score, only these first 2 decimals are really going to help me. So I'm going to go ahead and round this up. 5 or greater, you round up. So I'm going to round this up to 6.3. Okay, so I have a z-score of negative 1.63. Now, I'm also going to, in this area, I'm going to use the table and find out the probability from the table. So, first of all, you need to write your symbols. So, I'm looking for the probability that any given x value is going to be, see how it's to the left, so less than negative 1.63. All right, that's what I'm looking for. Okay, so we need to find negative 1.63 on the chart. Please understand that whatever number we find, it's giving us the probability to the left of the z-score. And that's exactly what we want in this case. So, negative 1.63. So make sure you're on the part of the chart that has the negatives on it. I see my negative 1.6 right here already. Okay, there's my negative 1.6. The last digit, okay, the 3 of negative 1.63, tells me which column to look at. Okay, so I've got the negative 1.6, but looking up here, because it was negative 1.63, this is the column that I'm going to look at. Okay, the 0.3 column. So I'm going to make sure I'm looking in this column. All right, so if I go to negative 1.6 and then I go over to the column that has the 0.3 in it, then this is the value that we are talking about. Okay, 0.0516. So 0.0516. Okay, and that as a percent, moving the decimal twice, that is 5.16%. Now, sometimes we want the decimal, sometimes we want the percent, but in this case, the question itself says what percent. So I definitely want the percent. So this is the answer, but we're not done. Okay. Okay, so we did the picture of the original value, but now you also have to draw a picture of the standardized form with the z-scores. So go ahead and draw yourself another bell curve, another normal distribution, if you will. Okay, but this time, instead of putting the mean, as 266, go ahead and put 0, because instead of dealing in days, okay, because that would be 0 days, that wouldn't make any sense, we're talking about z-scores. Okay, so this label of z-scores is mandatory. If this label is missing, you will be losing some points. Okay, this 0, mandatory. Okay, so instead of our mean, we put 0. This 240, we're going to mark that same spot on our picture, but instead of putting 240, we're going to put the z-score, which was negative 1.63. So this was negative 1.63. And we're still interested in the part that is below this value, so you're still shading the left side. Okay. So this is the picture that we had to have. Now this 5.16, let's go ahead and put that in our picture, because this red right here is 5.16% of the data. All right, and so that is the third step, the picture just like this. The fourth and final step is to write a sentence answering the question, in English. So it's saying what percent of pregnancies last less than 240 days. So we will say something very much like this. Okay, 5.16% of pregnancies last less than 240 days. All right, and that is it. So kabam, let's just take a step back. this is what I should see on your paper for this type of problem. Okay, not doing a good job of zooming right now, but you get the idea. If you had to copy off of me for most of that, or shame on you, like you shouldn't be copying, obviously. You should be, if you had to watch this video to learn how to do it, please make sure you go back now and do the problem yourself. All right, heaven forbid you just copied off of me. You should pause the video and do the next one by yourself and just check your answer. All right, copying off of me won't teach you anything. Okay, let's move on to the next one though. All right, so part B. What percent of pregnancies last between 240 and 270 days? Okay, again, your first step is to draw your distribution, this bell curve. All right, put your line down the middle for the mean. We're still dealing with the same overall situation. So the mean is still 266. Okay, so it says between 240 and 270. All right, so 240, isn't that the value we just did? Okay, so that's helpful because we already did that value. So 240 is over here, obviously. Now 270 will be over here somewhere. Okay, if we want to know the percent of pregnancies that last between 240 and 270 days, then that means we are interested in the percent that is between these two values. So this is the area that you should be shading in, the area between these two numbers. The label is very important, so make sure you put days as a label of your graph here. So that's it for step 1. All right, step 2 down here is to make sure we have z-scores for all of these and pull the probabilities and percentages from our chart. Okay, so first of all, the z-scores. So first of all, a z-score, if we're talking about 240, maybe I'll just do it this way. Whoa, crazy talk. Who hit me? All right, let me try this again. I'm just going to do it this way. I'm looking at a value of 240. Okay, this gave us a z-score, and I'm just going to copy it down because we already did it. All right, remember 240, that came out to be negative 1.63. So I'm just going to copy it off of the other problem. So negative 1.63. Okay, on the other hand, all right, let me just create a little extra space up here. On the other hand, now let's deal with the 270. All right, that's new. So for this one, I'm going to actually do the little formula. So my z-score should be 270 minus 266 divided by 16. Okay, and I'm just going to put that in my calculator. All right, I just got 0.25. Okay. Okay, so I have a z-score of 0.25. All right, now let's put that into probabilities. So we're trying to find the probability that our x value is between these two numbers. So what we need to do is we need to do negative 1.63 is less than x, which is less than 0.25. All right, you must write these symbols down. This is how you do between two z-scores. You put x and you put it between these two numbers. Always use these less than signs. Okay, all right, well, we're going to need the decimals off the chart for both of these, and we're going to subtract. We're going to wind up doing the big one minus the small one. Okay, all right, so let's do the big one first, the 0.25. To the chart. So 0.25, I need to look at the positive side of the chart for that. So here's 0.2. If I want the 5, I need to go over to where the 5 is. So I'm looking at this value right here then. All right, so that is 0.5987. Okay, so I've got 0.5987. Now if I want the probability between these, I need to do a subtraction of these probabilities. Okay, so the lower one, we already did it before, so I'm just going to look back and see what we got. When we had negative 1.63, that came out to be a probability of 0.0516. So we'll do minus 0.0516. So just put that in your calculator, guys. And I am getting 0.5471. And of course, this is the same as 54.71%, which is really going to wind up being the answer to the question. Okay, but before we can just answer the question, we need to do step 3, which is to draw this picture only using z-scores instead of these actual values. So in fact, I'm just going to cheat, and I'm going to literally cut and paste this. All right, so if I cheat right now, is this going to work? All right, let me see if this is going to work. All right, because it really should be the same picture. All right, just with a couple of changes. All right, we're not doing days. We're doing z-scores. So make that change. And instead of these 3 values, okay, instead of the mean, I have 0. Okay, and then instead of the actual values, the days, I'm now going to put the z-scores that go with them. Okay, so that was negative 1.63 and 0.25. So negative 1.63 and 0.25. Okay? And let's go ahead and include the percentage that we found. So between here, it should be 54.71%. Okay, so this is 54.71%. All right, is between here. All right, so this is really the picture of what we wanted. Now let's go ahead and write our sentence. Okay, and we're going to say, let's see, 54.71% of pregnancies last between 240 and 270 days. And there you go. That should be your answer to number 1, part B. Okay, let's do that a couple more times. All right, I'm going to start doing it a little faster now that I've done 2 examples already. Okay, what percent of pregnancies last longer than 280 days? Okay, so here we go again. We draw our curve. Okay, the mean is still 266. All right, we are interested in 280 days. This time we want to know what percent of pregnancies last longer than 280 days. So we'll shade in the part that's going to the right. Okay, time to find our z-score from 280. Okay, so our z-score will have 280 minus 266. Over 16. All right, I'm getting 0.875, which I'm going to round to 0.88. All right, 5 or higher, you round up. All right, time for the symbols. Not optional. We need the probability that x is greater than 0.88. Okay, because we want the values that are higher than 280 days. Okay, and we're going to pull this off the chart, sort of. Please remember that the values on the chart are all values that are to the left of the z-score. Okay, they're always to the left. So if I want to know the percentage that's to the right, I need to subtract from 1 to get the other part. So anytime you're doing to the right of the value, anytime you're doing greater than the value, when you get to the table, you're always going to wind up doing 1 minus the number. Okay, because the table value is always a left value. So we're looking for 0.88 on the table. Okay, so here is 0.8. So I need to go over to the 8 column for the second 8. So this is 0.88. So this is our number, 0.8106. So I'm doing 1 minus 0.8106. Did I read that right? Yeah. Okay, put that in your calculator. That is 0.1894. which is the same thing as 18.94%. And that's going to wind up being the answer to our question. Okay, but we're not done because we still have to draw a picture and make a sentence. So here comes our z-score picture. Okay, so our z-score picture is going to be like this. Okay, in the middle, we're always going to have 0. Okay, our z-score now, instead of 280, I'm going to put the 0.88. Okay, and we were looking at the values that are greater than this. You must write down the word z-score. Z-scores for full credit. So there's our picture, and now our sentence. So let's see. Okay, 18.94, right? So 18.94% of pregnancies last longer than 280 days. Okay, there you go. Kabam. All right, so that's what part C should have been looking like, bird's eye view. All right, now on to the back page. All right, We just got 3 more of these things. I'm going to do them as fast as I can. Okay, we're dealing with scores on an intelligence scale. Okay, for a certain age group. Approximately normal, we got your mean and our standard deviation. All right, so let's go ahead and draw our normal distribution bell curve thingy. Okay, something like that. I didn't leave a lot of space down here. Maybe I'll just redo it real quick. All right, we'll drop that mean right down the middle like we always do. Let's see, they said the mean is 110. So there we go, 110. Standard deviation is 25, good to know. All right, what proportion of the people aged 20 to 34 have IQ scores above 100? Okay, so 100 is a little bit to the left. Okay, so we'll just throw 100 over here. Okay, they said above 100, so that means you should shade in this part of the graph. Okay, because this is the part that's above 100. And these are, let's see, we need the units. Well, it's just a score, so I'm not really sure what to put for the units. Maybe I'll just put units for right now. Okay, whatever, units. Now, let's go ahead and turn this into a z-score right now. Okay, so we'll have a z-score. For the z-score, we do 100 minus the mean divided by the standard deviation, which I believe we said was 25. Yep, standard deviation 25. Okay. All right, that comes out to be negative 0.4. Okay, so that's my z-score. Let's go ahead and use our symbols to show what we're looking for. All right, we're looking for the probability that x is greater than 100. All right, so now remember, if you want to find a value that's greater than, wait, I shouldn't have put 100 just then. All right, we're dealing in z-scores now. So we're looking for the probability that x is greater than negative 0.4. Almost messed up right then. Negative. Okay, so like I was saying, if we're doing greater than, the chart here only does less than. All right, it's automatically giving us probabilities to the left. So if I want to go to the right, remember I have to do 1 minus the value from the chart that I'm going to get. Okay, so I'm going to look up this z-score on the chart, but 1 minus that. So negative 0.4. So make sure you are on the negative side. So there's negative 0.4. And I didn't have any extra decimals. It's just 0.4. So that's when I just use the 0 column, negative 0.4, bam. Not 0.1, not 0.2, just 0.4, period. So this is the value I need, 0.3446. Okay, just put that in your calculator and see what you get. So 1 minus 0.3446. Okay, that's giving me 0.6554, which is the same thing as 65.54%. Okay. Now, don't forget to make your z-score graph, your z-score picture. So same thing. Using z-scores, right? The z-score graph will always have 0 in the middle. You must write the word z-scores over here. Okay, we were doing the 100, which had a z-score of negative 0.4. Okay, so here we are over here, so that's negative 0.4. We were doing greater than this. Okay, which turned out to be 65.54%. Okay, so then the sentence. We were talking about what percentage of, what proportion of people have IQ scores above 100. We're talking IQ score. So right here when I said units, let's just put IQ scores. Okay, IQ scores above 100. So now we will do our sentence. So we will say 65.54% of people have IQ scores above 100. Okay, now they gave us a specific age range, so we should mention that. So this is just for people aged 20 to 34. Okay, ages 20 to 34. Okay, so 65.54% of people ages 20 to 34 have IQ scores above 100. Okay, that is it for that. And I'm gonna have to stop this video here. I have to go to a meeting. And I've done, this is a fourth example I've done for you. You really should be getting the idea. If I have time, I'll come back and do the other two problems in a separate video. But if not, that should be plenty to get you started and show you how to do it. All right, the rest of these problems are really just like the ones I already showed you. So you should be good to go.